Welcome. So in this video we are going to use a GeoGebra applet that was created by Marc Renaud from Shippensburg University to estimate the graph of the derivative of a function given the graph of a function here given in black. So in black we have a function, let's call it f, and what we want to do is graph f prime. Now to do that, we will adjust these dots here by moving them upwards or downwards to create the graph of f prime. So the graph of f prime will be in blue. Now, the first thing I try to start with is to look at places on the graph of f where the slope of the tangent line is 0, so where the tangent line is horizontal. So for example, there's here, here, and here where the tangent line is horizontal, which means that at roughly here, here, and here, my derivative should be 0. So the graph of f prime should cross the x-axis. So I'll just try to adjust things slightly. You see, so here, okay, my line crosses the x-axis. Should cross the x-axis somewhere here. So I'll just adjust this here, and same goes here. So maybe I'll just move that down or do that a little bit like that. Okay, so it crosses the x-axis here. I may have to adjust those points. So it's just for now I have the right points where my derivative crosses the x-axis. Let's just keep that in mind, that I need the derivative to go across the x-axis here, here, and here. Afterwards, okay, let's worry about where my derivative is positive or negative. So a positive, or well, let's start with a negative derivative occurs when the slope of the tangent line is negative. So for example, you see here the slopes are negative because if I draw tangent lines, you can see that their slope is negative. So my derivative should be negative on this interval here, and it actually is already. But I can do better than that. I can actually estimate slopes. So for example, here, what would be the slope? If I draw an imaginary tangent line, you can see if I go forward by 1, I'm going down almost by 1. So a slope of -1 might be correct. And the slopes are getting less and less negative, so that means that my derivative should be increasing on that interval, and it is. So that's probably a good estimate of what f prime looks like here. So I'm going to try to do the same on the other interval. Let's say from here to here. So on this interval, what does the graph of the derivative look like? Other points that are relatively important are points where your derivative is the most positive or the most negative. For example, here you can see that it's probably where the tangent line has the steepest slope. What would it be? Again, if I draw an imaginary tangent line, you can see if I go forward, that's almost straight, right? So if we go forward by 1, we go up by 1.6, something like that. So here, my function value should for f prime should be at 1.6 somewhere. So I'm going to move those up maybe like that, maybe a little more. And okay, maybe even more. There we go. Okay, so it's the steepest here. Oh, that's yeah, we're crossing the x. I'm still checking if I'm crossing the x-axis at the right place. So I've slightly adjusted my curve so that my slopes are increasing. As you can see, they're quite negative. They become 0, and here it should be the largest positive value for f prime. That's where I have so you can see I have a maximum for f prime here. So that's pretty good. And then afterwards, the slope are decreasing in value because this is where I'm the most, a slope that's the most positive, and then we I have a slope that is 0 here, so I should have my function f prime decreasing from roughly, yeah, maybe here I also have to adjust that point. So it has to be decreasing, so let's adjust it a little bit. Okay, so it crosses the x-axis here, so I'm fairly happy. After that, it's still decreasing because the slopes are becoming more and more negative. That's probably, I don't know where, here where it's the most negative. Okay, what would the slope be like? This is almost straight. So if we go forward by 1, we go down from here to here. So roughly 1.7, right? If we go forward by 1, we went down by 1.7. So the slope would be minus 1.7, something like that. I'll just adjust this slightly here. Okay, I want my curve to kind of look smooth. And and then I'm becoming less and less negative, so my derivative will be increasing from here all the way to here. So I want to have an increasing function. Okay, it crosses the x-axis still here. Okay, that's good. And after that, it's still the slopes are still increasing, and it's probably the most positive here. So let's estimate what that would be. I'll draw an imaginary tangent line. So if we go forward by 1, we go up by what, 1.2? I don't know. So something like that. There we go. Okay. So I'm fairly happy with what I have here now. So this is my guess for f prime, and if I click on check accuracy, it will tell me how good my estimate is. So it's 91% accurate, which is not bad actually. And with show results, I can actually look at what the actual function f prime would look like. So you see, I didn't do so bad. So keep those ideas in mind when you graph f prime. Specifically, look at the important points are where the tangent line is horizontal. That's where your curve will cross the x-axis. So we have 3 values here. And look at also points where your tangent line is the most positive or the most negative. Those should be minimums and maximums for your curve f prime. Thank you for listening.